I am Tom, and in this video I am going to show you how to find the gradient of a function, and we will also take a look at a graphical interpretation of the gradient as a vector in the xy plane. So this is all occurring in the context of multivariable calculus. So you're given the following function, and we'll say it's a function f with the variables x and y, and say is given by x squared plus y squared. To form the gradient, what we need are the partial derivatives with respect to x and with respect to y. So what we have is f with a little subscript of x. This is the symbol for a partial derivative. And this is equal to, and now you take the partial derivative of the function, so that is 2x. Then we will find the partial derivative with respect to y, which is just 2y. And once we have these two pieces, we stick them into a vector. And we use this notation, we use an inverted triangle. F xy equals 2xi plus 2yj. So this is a vector that depends on where you are located because it's a function of x and y, of the coordinates, meaning where you are located in the xy plane. So let's draw an xy plane, x-axis, y-axis. Let's label them x and y. This is our function x squared plus y squared. This is the partial with respect to x, the partial with respect to y. You place them inside a vector like this. This is what we call the gradient vector. So the gradient of f of x and y is 2xi plus 2yj. To review, I is the unit vector along the x-axis and j is the unit vector along the y-axis. So these are our little unit vectors. This is 1i and this is 1j. And then you can see that the gradient is a linear combination of these two unit vectors, and it's a function of x and y. So what we are going to do is now plot the gradient at one point in the plane. And to do this meaningfully, let's take a look at a couple contour curves of the function f. So that comes from taking the function and setting it equal to a constant. Now this is a circle of radius 1. So that's a very small circle that looks like this. Let's take a look at another contour. Okay, so say this is now 4. This is a circle of radius 2. So it looks like this. X squared plus y squared equals 9. This is a radius of 3 in our circle. So we do this. X squared plus y squared equals 16. This is a radius of 4. So what we are going to do is draw a picture of the gradient at the point, well, several points, why not? Okay, so first let's mark the gradient at the point 4, 0. Okay, we'll draw a picture of the gradient at the point 4, 0. Now let's review also the meaning of the word gradient. The word gradient simply means slope. So what you have here is a glorified slope, so to speak. Notice this is a slope in the x direction. This is the slope in the y direction at every point. Okay? So the gradient is just a fancy way of saying slope. You can also think of it as a rate of change along the x-axis and a rate of change along the y-axis put together into one quantity. So it's the total rate of change, so to speak. So at the point 4, 0, the gradient looks like this, okay? the gradient of f evaluated at the point 4, 0 is 2 times 4i plus 2 times 0j, which is 8i. So here what you would do is draw from the point 4, 0, and that's 8 i's, so that means you will go 8 to the right starting from the point 4, 0. So let me draw that in. That will take us all the way to positive 12. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. So the length of that blue arrow is 8, and it represents the rate of change of the function at the point 4, 0. So imagine this is a function, of course, of two variables. This is a paraboloid, and it's in 3 dimensions. Okay, but along the x-axis, at the point 4, 0, the rate of change of the function is given by 8i. Okay, let's evaluate it at the point here. So this is now 1, 2, 3, 4, or 0, 4. Let's see what the rate of change of the function is along the y-axis here at the point 0, 4. So the gradient of f evaluated at the point 0, 4 is 2 times 0i plus 2 times 4j. This is simply 8j. So what we can do is the same thing as before. We draw an arrow of length 8 from here to 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that blue arrow that I've drawn over here is the gradient evaluated at the point 0, 4, and it is a magnitude of 8, has a length of 8. It represents the rate of change of the function at this point along the y-axis. And now we can also find the rates of change along this contour curve, or perhaps this one. And in each case, what you do is, once you find it, you draw an arrow that is perpendicular to the contour. Okay? So to review, what we have is the following. You have your function, x squared plus y squared, usually given to you. You should know how to find a partial with respect to x, a partial with respect to y. You should know how to form the gradient of the function by applying this technique. Yes, you stick the partials into a vector. This goes along the x-axis, and the partial with respect to y goes along the y-axis. This is a function of position, meaning of x and y, which means that depending on where you're located in the xy plane, you get a different quantity every time. In this case, the function x squared plus y squared can be drawn in the xy plane, meaning its level curves can be drawn by setting x squared plus y squared equal to 1 and drawing that. X squared plus y squared equals to 4 is a circle of radius 2. So this is a radius of 1, this is a radius of 2, this is a radius of 3, and this is a radius of 4. And here I've concentrated only on the first quadrant for the sake of simplicity. Then you evaluate the gradient, for example, at the point 4, 0. You replace x with 4, y with 0, and all that remains is 8i. So at this point, you draw an arrow of length 8 pointing to the right. At the point 0, 4, you draw another gradient vector, and that is just 8j. So you draw an arrow from this point up 8. And the physical meaning of the magnitudes of these quantities is they're the rates of change of the function in that direction, in this case. Just to review, take a look. Imagine you had just f as a function of x, defined by x squared. Then you differentiate this, so f prime of x would be equal to 2x, and then the slope, let me put commas here, at positive 4 would be equal to 8, you see? So in other words, the gradient really is just a very kind of complicated slope. Thank you for watching.